Right, well, here we are. In our previous video, we test drove the development of a basic FizzBuzz program. Now, this FizzBuzz program worked something like this, where we were asked to input a positive integer, let's say 1, and we are given a FizzBuzz result. So FizzBuzz result for 1 is 1, for 2 it's 2, for 3 it's fizz, 4, and 5 is buzz. So any multiple of 3, let's say 6, will get us fizz, 3, 6, 9, 12. And any multiple of 5, like 10, will get us buzz. 15 will get us FizzBuzz. It will get us FizzBuzz, and so will 30. Any number less than 1 is an invalid integer. -2, once again, it'll just say please input a positive integer. And -1 quits. If you want to see how to make that program, the link to that's going to be in the description. But right now we're going to talk about how to refactor code. Because I showed you just how to write basic tests and go and make functional code from that. Now, the tests don't necessarily read as well as they could. So we can go and refactor the tests and the code to make it work a little better. So the first thing we'll find is here on line 8, we make a new FizzBuzzer. On line 9, we test the we get the output. And line 10, we assert that the tested output equals something. Now this doesn't necessarily read as well as it could, but we're using the JUnit test library, so this is basically what we're going to wind up getting. And then if we run the tests, we find out that all of them pass. So the program works as intended. And you get to see within the JUnit test framework that, okay, what should happen versus what does happen. And let's say, for example, when input is -10, then return invalid output. But if we say, okay, if we want it to be something else than that, it will fail. And the test will then the result of the test will then read expected something else but was invalid output. So we'll undo all that and focus on what we can do to make our tests more readable. We'll run our tests again and see that they're all working. So what can we do? Well, one of the first things we can do is get rid of this line 8 and line 15 and line 22 and so on, because we're copying code. So whenever we copy code, we can go and extract a method. So we can say something like, we'll declare under test. And now we have an under test FizzBuzzer to play with, test, and so on. And we can use a different annotation than our test annotation. We can use the before annotation, and this will then be performed before every test. So we can go and call it something like initialize, and then we can say, okay, when we initialize under test is a new FizzBuzzer. That's nice. And then we can import before. So what's nice now is that before every single test, we have a new FizzBuzzer to test. So if we do something to the FizzBuzzer at some later stage in our testing, we'll run one test, and then we'll start up with the same new FizzBuzzer before we run our next test. So now we know that this line we don't need anymore. Poop, it's gone because we have a new FizzBuzzer every test. So that line is gone, and that line is gone, and that line is gone. This line is gone. We had 10 tests. Every single one of these does not need declaration or the instantiation of our FizzBuzzer because we already made it. So that's nice. So now we've made our tests all shorter. So what we're doing on a consistent basis, it seems like we're going and making a test output string, going and filling it with the result of a particular test, and then asserting that the output is something that it should be. So what happens if we decide that we want to have some sort of a method, let's say test FizzBuzzer, and then we can have, of course, FizzBuzzer under test string expected result int FizzBuzz number. I don't know if that works, but at least it kind of makes sense. We're going to test a FizzBuzzer. We throw in a FizzBuzzer. We pass a FizzBuzzer, an expected result, and a FizzBuzz number. Then if we go and we take this as an example, we can start with the assert because that matters. We're going to assert that expected result is actual result. But we don't have a string actual result. So how do we make the string actual result? We make our local variable. Oopsies. We can call it a string. We can call it a string. Make it a type string, and then we'll say our actual result is what happens when we test our FizzBuzzer with the FizzBuzz number that we passed. And so that means that we can replace this. We'll check to see if our test still passes. If we test FizzBuzzer under test with a string of invalid input and our FizzBuzz number there is 0. So this should then be an equivalent piece of code to what we have commented out here beneath. So we'll save and we'll run our test, and it seems that all of our tests are still passing. So before I get rid of the commented code, we can just go and rewrite this one. And this time we want to have a result of 1 when our integer is 1. Okay, and I'll just actually get rid of the code. I'll get rid of all this stuff that we don't need. And this is going to be the test for 2. test FizzBuzzer. And we want the result to be 2, the string 2 when we pass 2. And we want, for 3, we want it to be fizz. Oh no, we want fizz. Fizz for the number 3. And we want fizz to also be there for the number 6. So we test FizzBuzzer. And when input is 5, we want it to return buzz. Our input is 5, we want it to return buzz. So then we can go and test our FizzBuzzer and say that it should be saying buzz when our input is 5, and that it should be saying, I'm going to be a bad one, I'm going to copy and paste and say it should return buzz for 10 as well. When it's -10, it should return invalid output. Invalid output. And when input is 15, we want it to return FizzBuzz. And the same for when the input is 30. So we're going to go and see what happens if we go and do that. I've gone and written quite a few tests, but let's just make sure. We'll save and run. What did I do? Oh, should you say invalid input? See, this is why copy pasting is kind of a bad thing, because we don't actually know what we want. It said here that we wanted it to be expected invalid output, but was invalid input. And well, we want it to return invalid input when it's -10, because -10 is not a number that we're going to actually give a FizzBuzz result for. So we go and we save that, and we run our tests, and all of our tests pass. So we've cleaned up our FizzBuzz test code. Now, let's clean up our FizzBuzzer. So what we can do is we can extract some methods. So here we're saying that if our FizzBuzz number is less than 1, we want it to return an invalid input. Okay. We don't need that auto-generated method stub. So we'll get, oopsies, what did I do here? Got rid of it. Okay, good. So we'll make a private method, and we're going to call it, going to extract a method. It's going to be a private method, and we're going to call it isInvalidInput. So if it is an invalid, if our FizzBuzz number is an invalid input, return invalid input. And see, now we have a method here that is, it returns a Boolean, and it simply returns whether FizzBuzz number is less than 1. So there goes that one. We refactored that part, and of course we can go and save and run our tests and find that all 10 of them still pass. So we did. Now, this seems to be a little bit of weird logic, so we might have to go and rethink this a bit. So we can call FizzBuzz number mod 3 equals 0. So if it's divisible by 3, we can return fizz. So we can go and extract a method. And we can call it is divisible by 3. We'll save, and we'll run, and all of our tests still pass. Now here we have on line 9 the same test, but only to see if it's divisible by 5. So we can go and extract a method here and call it is divisible by 5. And then we say else if is divisible by 3 and is divisible by 5, return FizzBuzz. So that answers all of these if statements. But I'm thinking that this might not be the most simple way of doing the code. I didn't think at the moment that it was necessarily the most simple way of doing the code, but it was the most illustrative. But now we're going to have to go and rethink. Because here we have integer.toString FizzBuzz number. But what happens if we just return, well, I don't know, say FizzBuzz number plus an empty string? Or even better, if we return an empty string plus FizzBuzz number. So we concatenate FizzBuzz number to an empty string. Now the reason I'm saying that is because we may want to extract a variable from this. So we'll run and see that our tests still pass. So now we're returning fizz, we're returning buzz, we're returning FizzBuzz. But what happens if we say instead, and I'll comment this out, and we can go and think. What if we do if, or we'll start with our return statement. Oopsie, this one doesn't need to be commented out. We'll just move this one up a little bit. So we'll want to return, what do we want to return? We'll say that we'll return fizz buzz result. Or maybe we can just say response. I like result. So we're going to return result, and we don't have a local variable yet, so we'll make one. So now we have a string result and we return result, but now we're returning null because we haven't initialized it as anything. So we'll initialize it as an empty string. Okay, and now if we run all of our tests, they will all fail. Every last one of them will fail. So what if we say, and build it back up the same way that we did, let's say we wanted to get if it's not divisible by 3 or 5 or anything else. So we'll say if result, and here I am with horrible Java syntax, dot is empty. result plus equals FizzBuzz number. Okay, so we add the FizzBuzz number to our result if it's empty. If it's divisible by 3, if is divisible by 3, then what we're going to do is result plus equals fizz. Oopsie, there we go. And if it's divisible by 5, then we will concatenate buzz. Now, the only problem is, I don't know, let's go and run our tests. Let's run our tests. So when input is negative, then return invalid input, so that doesn't work yet. When -10, when it's less than 1. When input it was 30, then return FizzBuzz. When input is 15, then return FizzBuzz. So we'll read our test thing. It expected FizzBuzz, but was BuzzFizz. So I'll show you here by running the app. If we run the console app, what that logic does is if we go and input 3, we still get fizz, and if we input 5, we get buzz. But if we input 15, we get BuzzFizz. And why does that happen? Well, what we want is for it to concatenate the fizz to the front of the buzz, or rather the buzz to the back of the fizz. But if we're going to be seeing that 15 is divisible by 5 and 3, it's just going to go through these statements in order, so buzz will come first. Buzz, fizz. So the simple thing to do is just reorder the if statements so that we add buzz after any fizzes. We add buzz after any fizzes. Now we save it. Now we can run our test, and the only ones that are going to fail is when we have -10 or 0 when input is less than 1. So we'll actually change the name of this one to when input is 0, return invalid input. So that one failed. And now if we run all of them, those 2 fail. So now we just have to go and say if is invalid input FizzBuzz number result plus equals, so concatenate invalid input. And that should what did I do wrong here? Ooh, that's kind of spicy here, because now 0 is technically divisible by 3 and 5. So we don't want to add that to the result. What we want to do is return invalid input. So you can see, I'll show you in the app again because it's a little bit more clear than reading the test failure. What that code does, if we run our app and we type in input 0, it's going to say, please input a positive integer, input -1 to quit. Okay, so the app is doing what it's supposed to be doing. The app is doing what it's supposed to be doing, but the FizzBuzzer isn't. The FizzBuzzer is still returning invalid input FizzBuzz. This is returning invalid input FizzBuzz because it's evaluating both whether or not it's an invalid input and if it's divisible by 3 or 5, and 0 is both divisible by 3 and 5 evenly. So what we'll want to do is change this to return, and then it will bypass all this other stuff here, and we can save test first, and all of our tests pass, so we can get rid of this previous code because we don't need it anymore, and review exactly what it is that we did. We'll make this look a little nicer. We first refactored the code to see, is it an invalid input? So basically, is it less than 1? Is it divisible by 3? And is it divisible by 5? And now we have our actual FizzBuzz method. And we return invalid input if it is an invalid input. Otherwise, we concatenate fizz and buzz if it's divisible by 3 and by 5 respectively. If you get through this and there is no fizz and there is no buzz, we just put the number in, and that's enough. So we've gone and refactored our test and our FizzBuzzer. Now I'm certain there are other things we can do here in the app. Oh, we can see that I forgot to close our console input. So after our while loop is over, what we're going to want to do is close and that will get rid of that little problem there. So we did a little bit of debugging and a whole lot of refactoring. I know that we dealt with quite a bit and jumped back and forth a lot in between a lot of the different things. So if there are any lingering questions, I'll leave them in the comments section, but I suggest reviewing this video as much as you need to in order to make sense of things before you ask something that that you could already answer yourself. Once again, the previous app or the previous video is in the description below. I hope that this video has helped in terms of teaching a little bit about refactoring code. Until next time.